Welcome to our online lecture. To give you a background of this semester, the course on Electronics 3 is subdivided into two parts, the Power Electronics and the Industrial Electronics. For the first two quarters of this semester, our topic will focus on Power Electronics. And for the last two quarters of this semester, our topic will focus on Industrial Electronics. Let's begin. Have you already seen a motor? Para makontrol mo ang isang motor, it requires control sa electric power. And we will learn in power electronics how to build a control circuit to manipulate electric power. Power electronics have eased the concept of power control. Power electronics deal with the power equipment with power control. And power electronics based on switching of power semiconductor devices. At natutunan natin yung switching na ito during your Electronics 1. Kung paano nag-switch on and off ang diode and transistor. And ngayon, pag-aaralan naman natin ang mga thyristor. Pero bago ang lahat, let's have some review about power semiconductor devices. Power semiconductor devices are categorized into three types. First is diodes. Diodes are two-layer switching device. It has two terminals, the anode and cathode. It is commonly used as rectifier or converter from AC to DC, either half wave or full wave. Diodes are commonly used for low power system. At kung mapapansin natin, na ang power ni diode is up to 2.7 megawatts. Next is transistor. Transistor consists of three layers of semiconductor material. It has three terminals, base, collector, and emitter. Transistor is a device that regulates current or voltage flow and act as switch and amplifier. Last is thyristors. Thyristors consist of four-layer, three-junction semiconductor switching device. It has three terminals. They are anode, cathode, and gate. The main function of thyristor is to control high power circuits. Kung mapapansin natin na ang power ng thyristor is up to 30 megawatts. Ibig sabihin, it is designed for high power system. It can also be used as light dimmer, electric power control, and speed control of motor. What's the difference of thyristor with other semiconductor device such as diodes and transistor? Thyristor was commonly used for high power circuits. Ito ang nag-solve ng issue ng power losses, stability and controllability ng long power transmission. Long distance power transmission. What is a thyristor? Thyristor was introduced by William Shockley in 1950 and it was developed at Bell Lab in 1956. Thyristor is four-layer three-junction PNPN semiconductor switching device. It has three terminals, namely anode, cathode, and gate. Anode and cathode is responsible for the direction of current, while gate controls or allows the flow of current between anode and cathode. The figure at the right side illustrates the construction and symbol of a thyristor. Before I discuss how transistor work, let's have some review how transistor works. We all know that transistor can be BJT or FET, but let's make PNP BJT transistor as an example. The majority carrier at PNP BJT transistor are holes. Let us draw the PNP transistor without base, collector, bias, or supply. Ibig sabihin, ang meron lang dito is yung emitter voltage. Dahil dito, the depletion region between emitter and base region has been reduced due to applied voltage, resulting in heavy flow of majority carrier from P to N-type material. During forward bias, yung majority carrier natin again ay mga holes at emitter region ay nagmo-move toward the N-type region. Let's now remove the emitter voltage and place collector voltage. The flow of majority carrier is 0 dahil reverse bias. But still, because it is reverse bias, minority carrier can flow with a very small current called leakage current. Ibig sabihin, kung mapapansin natin, during forward bias, yung majority carrier, mga holes ng PNP transistor ay nagfo-flow during forward bias. But during reverse bias, the minority carrier of PNP transistor will flow toward the collector region. Okay, let's place the collector voltage and emitter voltage and applied it to PNP transistor. And this is the resulting diagram. The majority carrier and the minority carrier flows. Large number of majority carrier will diffuse from emitter to base region. The question is, will this diffuse majority carrier contribute sa current at the base region, or it will pass directly to collector region? Since base is very thin and low conductivity, a very small number of this carrier will take this path, but the large number of this majority carrier will diffuse across reverse bias depletion region into the P-type material on the collector region. And that's how transistor works. Ibig sabihin, sa emitter to base region, the majority carrier flows, and from base region to collector region, the minority carrier flows. Kaya magko-conduct at magsi-switch on ang ating transistor. Same operation with thyristor. A thyristor has 3 terminals: anode, cathode, and gate. When anode is positive with cathode and with gate circuit open, ma-observe natin na ang J1 and J3 is in forward biased. And ang J2 was in reversed bias. Kaya hindi magko-continue ang flow ng current from anode to cathode kasi merong depletion region sa J2. Kaya ang tawag sa mode na ito is forward blocking mode. Sa forward blocking mode, when forward voltage is less than the forward breakover voltage, thyristor is at off state because of high impedance. Sa forward blocking mode, mag-on lang ang thyristor kapag na-reach or above the forward breakover voltage. So, anong gagawin natin to turn on the thyristor? Increase the forward voltage. When the forward voltage is above or greater than forward breakover voltage, thyristor is at on state kahit open ang gate. Characteristic curve will show that a thyristor with open gate needs a forward voltage above the forward breakover voltage to turn on. As the anode to cathode voltage or forward voltage is increased, breakdown of the reverse bias junction J2 occurs. Kasi pag dumalaki yung depletion region, mas tumataas yung reverse current. Kaya ang nangyayari, nagkakaroon ng phenomena called avalanche breakdown. At this phenomena, electron drifts across the depletion region and allow current flow. What if I place the thyristor in reverse condition? When anode is negative with cathode, with gate circuit open, a thyristor is said to be reversed biased. J1 and J3 are reversed biased and J2 is forward bias. Ang tawag sa mode na to ay reverse blocking mode. In reverse blocking mode, let's look at the reverse condition at the characteristic curve at the right side. As the reverse voltage increases, critical breakdown called reverse breakdown occur. Avalanche happens on J1 and J3 and reverse current increases rapidly. This condition may damage the thyristor. In this mode, thyristor is out of state. Next is forward conduction mode. A while ago, we have discussed the forward blocking mode. To put the thyristor at conduction mode, thyristor conducts current from anode to cathode by exceeding the forward breakover voltage or exceeding the forward voltage o tinataasan natin yung forward voltage para malagpasan natin yung forward breakover voltage. This method is used for open gate circuit. What if I want to use the gate voltage without increasing the forward voltage or without exceeding the forward breakover voltage? Applying a gate pulse between gate and cathode will turn on the thyristor. Thyristor requires gate signal to turn it on. Once on, it behave like a rectifier or a diode. Kung magbibehave siya na parang rectifier, anong pinagkaiban thyristor at diode sa kanyang operation? Once the thyristor has been turned on and current is flowing in forward direction, it remains on even the gate pulses will be removed. Ibig sabihin, kahit alisin na yung gate, the thyristor is already working at on state na parang isang diode. The application of any gate pulses or signal will have no effect because the thyristor is already conducting and fully on. The conduction of current continues even if the anode-cathode voltage reduces below breakover voltage, till anode current will not go below holding current for the thyristor. Okay, note that yung anode current will be above, dapat above siya sa holding current para mag-remain yung thyristor at on state. How to turn off the thyristor? Once the thyristor is fully on, it can only be turned off by two ways: removing the supply voltage or reducing the anode current to go below the value of holding current. Let's summarize the characteristic curve of a thyristor. At forward blocking mode, J1 and J3 are forward biased, while J2 is in reverse bias. Thyristor is at off state if the forward voltage is less than the forward breakover voltage. And thyristor is in on state if the forward voltage is greater than the forward breakover voltage even without the application of gate pulse or gate voltage. At reverse blocking mode, J1 and J3 are in reverse bias while J2 is in forward bias. Thyristor is at off state when reverse voltage is less than the reverse breakover voltage. Thyristor is at avalanche breakdown if the reverse voltage is greater than the reverse breakover voltage. At forward conduction mode, application of gate voltage between gate and cathode set the thyristor at on state. Once the thyristor has been turned on, it remains fully on even the gate signal is removed. It remains at on state if the anode current is above the holding current. To turn off the thyristor, there are two ways: remove the supply voltage or reduce the anode current to go below the holding current. Let us now compare the waveform of power semiconductor devices. Diode acts as a rectifier and it has two waveform, the half wave and full wave. Transistor acts as switch or amplifier. It amplifies input voltage or input current. And last is the waveform of thyristor. How do this thyristor form this kind of waveform? In this diagram, we will see that gate pulse is a sinusoidal wave, and we will draw the output of thyristor. Like a diode, thyristor will conduct at only one cycle. The thyristor will only fire at positive half cycle, parang half wave rectifier. But it is not that simple because the gate has a minimum voltage in order to turn on the thyristor. Yan. Suppose that the minimum voltage is here. Therefore, during this part of the cycle, the thyristor is at off state. At sa point na to, dito lang nag-on ang ating thyristor. Finally, ito ang magiging waveform ng thyristor. The output at the start is 0 until it starts to conduct. We lose one part of the positive half cycle. To summarize the waveform, the broken lines is the applied anode to cathode voltage. And during positive half cycle, the thyristor conducts. While during the negative half cycle, the thyristor blocks this cycle or it does not conduct. Thyristor is at 0 until the gate voltage is above the minimum voltage. And this is the output of a thyristor. What are the parts of the thyristor waveform? In each cycle, there are two parts: the firing delay angle and the conduction angle. Firing delay angle is the number of degrees of an AC cycle during which the thyristor is in the off state. Conduction angle is the number of degrees of an AC cycle during which the thyristor is in the on state. Next lessons, we will further discuss about this. Hoping na marami kayong natutunan sa topic natin ngayon, and thank you for watching.